Most people think the espresso machine is the heart of great coffee. They spend thousands upgrading machines, changing pressure settings, adjusting temperatures, replacing accessories, and endlessly chasing the perfect extraction. But what most people never realize is that the grinder controls more of the final cup than almost anything else in the entire coffee setup. Long before water even touches the coffee, the grinder has already determined how evenly extraction will happen, how stable the shot will be, how balanced the flavor becomes, and whether the espresso will taste clean, sweet, bitter, sour, muddy, weak, or beautifully structured. And this is exactly why so many people struggle with inconsistency without understanding the real source of the problem. They blame the machine when the grinder is unstable. They blame the beans when the burrs are worn. They blame extraction when the grind size distribution is collapsing underneath. The grinder silently controls everything, and most people barely understand how it actually works internally. One of the biggest reasons grinders are misunderstood is because their problems are often invisible at first. A machine leak is obvious. A broken steam wand is obvious. A pressure issue is obvious. But grinder problems usually appear indirectly through flavor instability, inconsistent shot times, channeling, clumping, static, retention, or extraction unpredictability. And because people only see the final espresso result, they rarely realize the grinder itself may already be creating instability long before brewing even begins. This is what makes grinder diagnostics so important. Small inconsistencies inside the grinder create massive inconsistencies inside the cup. Tiny burr misalignment. This course is not just about cleaning grinders or replacing burrs mechanically. It's about developing real technician understanding, learning how grinders behave internally, how grind consistency affects extraction, how mechanical wear changes performance, how calibration influences resistance, and how professionals diagnose grinder problems systematically instead of guessing randomly. Throughout this course, you're going to learn how to observe grinder behavior like a technician, how to identify hidden problems before they become expensive, how to maintain grinders for long-term consistency, and how to think logically about whether you're a home barista trying to improve espresso consistency, a cafe owner struggling with grinder performance, a coffee enthusiast obsessed with extraction quality, or an aspiring coffee technician wanting real diagnostic skills. This course was designed to give you practical, real-world grinder knowledge you can apply immediately. You do not need advanced technical experience to follow this training. What matters is curiosity, observation, and a willingness to understand how grinders actually behave beneath the surface. Because the truth is, most grinder issues are not complicated once you understand the systems creating them. Inside this course, you'll learn how grinders function mechanically, how burr geometry affects extraction, how to identify wear patterns, how to diagnose grind inconsistency, how to calibrate grinders for espresso and filter coffee, how to reduce static and retention, how to troubleshoot motor and electrical problems safely, how to clean grinders properly without damaging components, and how experienced technicians approach grinder problems step by step using structured diagnostic logic instead of trial and error. You'll also learn how grinders interact directly with espresso extraction itself, because diagnosing coffee problems correctly requires understanding both systems together, not separately. Because in the end, great coffee doesn't begin at the espresso machine. It begins at the grinder. And once you understand the grinder properly, everything downstream, extraction, flavor, consistency, workflow, and diagnostics, becomes dramatically clearer. So in the next chapter, we're going to start at the foundation and break down exactly how coffee grinders actually work internally, why grind consistency matters so much, and how grinders shape extraction long before brewing ever begins. Before you can repair a grinder properly, maintain it correctly, or diagnose inconsistencies with confidence, you first need to understand something deeper than cleaning routines or adjustment settings. You need to understand what the grinder is actually doing to the coffee physically every single second it operates. Because grinders are not simple crushing machines. They are precision particle control systems. Their entire purpose is to take roasted coffee beans and transform them into particles with enough consistency, uniformity, and structure to allow water to extract flavor evenly during brewing. And the moment that particle consistency becomes unstable, everything downstream begins collapsing slowly. Extraction balance, shot timing, sweetness, clarity, texture, body, flow resistance, and overall cup quality. This is why experienced technicians and high-level baristas obsess over grinders so much. Because the grinder determines the foundation that every extraction is built on long before the espresso machine even becomes involved. At the most basic level, a coffee grinder performs one essential task: reducing roasted coffee beans into smaller particles. But what matters is not simply making coffee smaller. What matters is controlling how evenly those particles are produced. Because brewing is fundamentally a surface area interaction between water and coffee. When water passes through coffee grounds, it extracts soluble compounds from the outer surface of every particle. Smaller particles extract faster because they expose more surface area. Larger particles extract slower because less surface area is available relative to their size. This means that if a grinder produces wildly inconsistent particle sizes, extraction immediately becomes unstable. Some particles over-extract while others under-extract at the exact same time. The result is muddy flavor, bitterness mixed with sourness, weak sweetness, harsh texture, and inconsistent espresso behavior. The grinder's job is not just grinding coffee. Its real job is producing controlled particle uniformity under pressure, speed, heat, and resistance continuously. Most beginners focus only on grind size itself. Finer, coarser, smaller adjustments, bigger adjustments. But experienced technicians and advanced baristas focus far more heavily on grind consistency than grind size alone. Because two grinders set to the same grind size can produce completely different extraction behavior depending on how consistently the particles are distributed. One grinder may produce tight, uniform particle ranges with stable extraction behavior and balanced sweetness. Another may produce excessive fines, large boulders, clumping, and irregular particle distribution that creates unstable flow and chaotic extraction underneath. This is why expensive grinders exist in the first place, not simply because they grind finer, but because they maintain more stable particle consistency under repeated use. One of the biggest misconceptions in coffee is assuming all grinders perform similarly as long as they break coffee into smaller pieces. But the mechanism used to grind coffee dramatically changes the final particle distribution produced. Blade grinders operate by violently chopping coffee beans unpredictably at high speed. There is almost no particle control. Some grounds remain extremely large while others become powder like dust. Heat builds quickly, consistency collapses, and extraction becomes unstable. Burr grinders operate completely differently. Instead of randomly chopping coffee, burr grinders crush and shear beans between precision machine surfaces designed to control particle reduction progressively and predictably. This allows burr grinders to create far tighter particle consistency ranges than blade grinders ever could. And this difference alone completely transforms extraction quality. Once people begin exploring burr grinders, another major topic appears almost immediately: flat burrs versus conical burrs. And while coffee culture often turns this debate into exaggerated internet arguments, technicians approach the topic more practically by focusing on behavior characteristics instead of hype. Flat burr grinders typically produce very uniform particle distributions with high clarity and separation in flavor profiles, especially in espresso applications. Conical burr grinders often produce a broader distribution with different mouthfeel characteristics and slightly different extraction behavior. Neither system is universally perfect. Both designs involve trade-offs involving heat management, RPM behavior, retention characteristics, alignment sensitivity, particle distribution, workflow, and intended brewing style. Understanding these differences helps technicians diagnose grinder behavior more accurately instead of assuming every grinder should behave identically. Many people assume grinders either work or fail completely. But experienced technicians know grinders usually degrade gradually long before obvious failure appears. Burr edges slowly dull. Alignment drifts. Retention increases. Motor performance weakens subtly. Calibration stability decreases. Internal buildup accumulates. Static behavior changes. Extraction slowly becomes less predictable. And because these changes happen progressively over time, many users adapt unconsciously without realizing their grinder performance has already deteriorated significantly. This is one of the biggest reasons grinder maintenance and diagnostics matter so much. Without structured observation, grinder decline often becomes normalized until extraction quality collapses dramatically later. At this point, you should begin realizing that grinders are far more than simple coffee accessories. They are precision extraction control systems influencing flavor, consistency, resistance, flow, and brewing behavior at the very foundation of coffee preparation itself. And once you begin understanding how grinders shape extraction mechanically and physically, diagnosing coffee problems becomes dramatically clearer. Because the grinder is often where instability truly begins. In the next chapter, we're going to open the grinder itself and break down the internal anatomy of modern coffee grinders piece by piece so you understand exactly how every major component functions, wears, and influences overall performance over time. One of the biggest reasons people struggle to diagnose grinder problems correctly is because they don't actually understand what's happening inside the grinder while it operates. Most users only interact with the outside, the hopper, the adjustment dial, the power switch, and the coffee grounds coming out the front. But underneath the exterior shell is an entire mechanical system working together under stress, vibration, heat, resistance, friction, and constant movement. And when even one component inside that system begins drifting out of alignment, wearing down, loosening, clogging, overheating, or behaving inconsistently, extraction quality starts changing immediately, often long before obvious grinder failure appears. This is why real technicians study grinders internally, not just externally. Because every grinder tells a story through the condition of its internal components. Burr wear reveals usage patterns. Retention buildup reveals maintenance habits. Motor strain reveals resistance issues. Alignment drift reveals instability. And once you understand how every internal part contributes to the grinding process, diagnosing problems becomes dramatically easier because the grinder stops feeling mysterious. Most people think the hopper is simply a container for holding beans, but technicians understand that hopper design actually influences grinder behavior more than most users realize. Bean feed consistency directly affects grind stability. Poor hopper geometry can create uneven feeding under low bean volume conditions. Static buildup inside the hopper can interfere with smooth flow. Commercial grinders under heavy café use may develop bean bridging, where coffee stops feeding consistently into the burr chamber despite beans still appearing inside the hopper. Even vibration behavior changes how beans settle and feed into the grinding pathway. Technicians pay attention to these details because unstable bean feeding creates unstable grinding resistance, and unstable grinding resistance eventually affects particle consistency and extraction behavior downstream. The burr chamber is the true heart of the grinder. This is where raw coffee beans are transformed into controlled extraction particles under intense mechanical pressure. Inside this chamber, burr geometry, alignment precision, rotational stability, and particle flow all interact simultaneously. The condition of this chamber determines whether the grinder produces clean, consistent particles or unstable, chaotic distributions filled with fines and boulders. Even tiny alignment shifts inside the burr chamber can dramatically change grind consistency and extraction behavior. This is why technicians inspect burr chambers carefully for wear patterns, coffee oil buildup, retention pockets, burr stability, mounting integrity, and signs of uneven contact. Because the burr chamber directly controls the quality of the grind itself. Burrs are not simply sharp metal discs crushing coffee randomly. They are precision-engineered cutting surfaces designed to control how beans fracture progressively during grinding. Burr geometry determines particle shape, distribution, flow behavior, heat generation, resistance characteristics, and extraction performance. Different burr designs create different grinding personalities. Some prioritize clarity and particle uniformity. Others prioritize body and broader distributions. Over time, burr edges gradually wear down from friction and resistance, reducing cutting efficiency and increasing particle inconsistency slowly. This wear often develops gradually enough that users adapt unconsciously without realizing extraction quality has already deteriorated significantly. Technicians therefore learn to recognize burr wear not only visually, but through taste instability, grind drift, shot inconsistency, and changing grinder behavior over time. The grinder motor does far more than simply spin the burrs. It controls torque stability, grinding speed, heat generation, resistance management, and overall grinding consistency under load. A stable motor maintains predictable burr movement even while dense coffee beans create resistance inside the grinding chamber. But as motors age, strain increases. Bearings wear. Heat rises. Torque consistency weakens. Electrical components degrade. Capacitors drift. Vibration increases. All of these factors subtly influence grinding behavior long before total motor failure appears. Technicians therefore pay close attention not only to whether a motor works, but how the motor sounds, responds, vibrates, heats up, and behaves during repeated operation cycles. The grinder motor does far more than simply spin the burrs. It controls torque stability, grinding speed, heat generation, resistance management, and overall grinding consistency under load. A stable motor maintains predictable burr movement even while dense coffee beans create resistance inside the grinding chamber. But as motors age, strain increases. Bearings wear. Heat rises. Torque consistency weakens. Electrical components degrade. Capacitors drift. Vibration increases. All of these factors subtly influence grinding behavior long before total motor failure appears. Technicians therefore pay close attention not only to whether a motor works, but how the motor sounds, responds, vibrates, heats up, and behaves during repeated operation cycles. Once coffee leaves the burr chamber, the grinder still continues influencing extraction through retention and exit pathway behavior. Grounds do not simply disappear instantly from the machine. Coffee particles travel through chutes, declumpers, dosing systems, and internal pathways where static, buildup, oils, and retention begin accumulating gradually. Retained coffee contaminates fresh coffee with stale particles. Static causes uneven distribution. Blocked pathways increase clumping and resistance inconsistencies. This is why technicians inspect exit systems carefully instead of focusing only on burrs themselves. Because poor coffee evacuation creates instability long after the grinding process initially finishes. Once you understand how grinders function internally, you stop seeing grinder problems as random, frustrating mysteries. Instead, you begin recognizing relationships between symptoms and systems. Inconsistent extraction begins pointing toward burr wear, alignment drift, or retention instability. Motor strain reveals resistance problems. Static buildup explains clumping behavior. Calibration drift explains unpredictable shot timing. Internal understanding transforms troubleshooting from emotional guessing into logical observation because you now understand what each component is actually doing underneath the surface while the grinder operates. At this point, you now understand the internal anatomy of modern coffee grinders and how every major component contributes to grind quality, extraction consistency, workflow stability, and long-term performance. And now that you understand the physical systems inside the grinder, we can begin focusing on one of the most important and misunderstood areas of grinder performance entirely: burr wear, alignment, calibration, and how tiny mechanical inconsistencies dramatically affect espresso extraction without most people ever realizing it. If grinders are the foundation of extraction, then burrs are the heart of the grinder itself. Everything ultimately depends on how accurately the burrs cut, crush, shear, and distribute coffee particles under pressure. And yet burrs are one of the most neglected components in the entire coffee workflow. Most people continue using worn burrs for years without realizing how much extraction quality has already deteriorated underneath. Others obsess over expensive espresso machines while their grinder burrs are misaligned, unstable, clogged, or drifting out of calibration daily. This is why experienced coffee technicians pay enormous attention to burr condition and alignment. Because even tiny inconsistencies at the burr level become massive inconsistencies during extraction. A few microns of misalignment inside the grinder can completely reshape particle distribution, flow resistance, clarity, sweetness, and espresso behavior downstream. And the dangerous part is that these problems often develop gradually enough that most users never notice the decline until consistency becomes severely compromised. Most people imagine burrs simply crushing beans into smaller pieces, but the grinding process is far more controlled and sophisticated than that. Burrs are engineered cutting systems designed to fracture coffee progressively through multiple reduction stages. As beans enter the burr chamber, they first break into larger fragments, then progressively smaller particles as they travel deeper through the burr geometry. Each stage influences final particle distribution differently. Burr shape, cutting angle, tooth geometry, rotational speed, and spacing all influence how coffee fractures mechanically. And because coffee beans are brittle, irregular organic materials rather than perfectly uniform objects, controlling particle consistency becomes an extremely delicate mechanical process. This is why burr quality matters so much. The burrs are not merely grinding coffee. They are shaping extraction behavior at the microscopic level. Every grinder burr slowly changes with use, even when the decline is not immediately visible. Coffee beans create constant friction, resistance, heat, and mechanical stress against the burr surfaces during grinding. Over thousands of doses, cutting edges gradually dull, surfaces polish unevenly, and the burrs lose their ability to fracture coffee cleanly and consistently. The result is usually subtle at first. Espresso becomes slightly less sweet. Clarity decreases. Shots drift unpredictably. Flow becomes less stable. More fines begin appearing in the grind distribution. Users compensate unconsciously by adjusting grind settings repeatedly without realizing the underlying problem is burr wear itself. This is why technicians never evaluate grinders based only on whether they still grind coffee. They evaluate whether the burrs are still producing controlled and repeatable particle distributions under real extraction conditions. Technicians learn to recognize burr wear through behavioral patterns long before catastrophic failure occurs. Espresso may suddenly require much finer grind settings than before. Shot times begin drifting inconsistently. Clarity disappears from flavor separation. The coffee tastes flatter, muddier, or less sweet even when the beans themselves are fresh. Grind consistency becomes unstable between shots. Excess fines increase. Heat buildup may become more noticeable during grinding. Calibration may drift more frequently. And in commercial environments, output speed may even decrease slightly under load. None of these symptoms alone automatically confirm worn burrs, but together they create behavioral patterns technicians learn to identify quickly through observation and experience. Even perfectly sharp burrs can perform badly if alignment is unstable. Burr alignment refers to how parallel and centered the burr surfaces remain relative to each other during operation. If burrs become tilted, uneven, warped, or improperly mounted, particle consistency collapses because different sections of the burrs begin grinding at different distances simultaneously. One side may create overly fine particles while another side produces larger fragments. The grinder still appears functional externally, but extraction becomes chaotic underneath. This is one of the most misunderstood causes of espresso inconsistency, because the grinder may still sound normal while particle distribution quality quietly deteriorates. Technicians therefore treat burr alignment as one of the most important variables in grinder performance. Calibration is not simply adjusting grind size randomly until espresso looks acceptable. Real calibration is the process of controlling burr spacing precisely to create predictable extraction resistance under specific brewing conditions. As burr spacing changes, particle size changes. As particle size changes, extraction speed changes. And as extraction speed changes, flavor balance changes. This relationship between burr spacing and extraction behavior is one of the most important concepts in all of coffee preparation. Small calibration adjustments dramatically influence shot timing, flow resistance, body, sweetness, acidity, bitterness, and clarity. Technicians therefore learn to calibrate grinders methodically while observing how the grinder responds under real extraction conditions instead of making emotional adjustments blindly. One mistake many beginners make is expecting brand new burrs to perform perfectly immediately after installation. In reality, new burrs often require a break-in period before reaching stable grinding behavior. Fresh burr surfaces contain microscopic machining irregularities that gradually smooth during early usage. During this phase, grind consistency, retention behavior, static, and calibration stability may shift slightly until the burrs settle into normal operating conditions. Experienced technicians understand this process and avoid overreacting to small calibration drift during initial usage. They monitor stability over time instead of assuming immediate perfection from fresh burr installations. One of the most important lessons technicians eventually learn is that grinders rarely fail dramatically all at once. Most problems emerge gradually through small inconsistencies accumulating over time. Burr wear, alignment drift, retention buildup, calibration instability, vibration changes, heat stress, and particle inconsistency, slowly shaping extraction behavior underneath. This is why advanced diagnostics requires patience and observation. The goal is not simply fixing catastrophic failure. The goal is recognizing subtle instability before it becomes expensive, frustrating, or destructive to coffee quality long-term. At this point, you now understand why burr condition, alignment, and calibration play such a massive role in extraction quality and grinder performance overall. And once you begin recognizing how these microscopic mechanical variables influence espresso behavior directly, diagnosing coffee problems becomes dramatically more logical and structured. But burrs alone are not the only source of grinder instability. In the next chapter, we're going to move deeper into real-world grinder problems by focusing on one of the biggest areas technicians constantly diagnose: grind inconsistency, clumping, retention, static, and the hidden causes behind unstable extraction behavior. There's a moment almost every coffee enthusiast eventually experiences. One day the espresso suddenly tastes incredible, balanced, sweet, smooth, rich, stable. Then the next morning, using the exact same beans, the same grinder setting, the same machine, and the same workflow, the shot behaves completely differently. Suddenly the flow speeds up. The crema changes. The taste becomes harsh, sour, hollow, or muddy. And this is where frustration usually begins. Most people immediately start chasing random adjustments emotionally. They blame the beans. They blame the espresso machine. They start changing temperatures, doses, pressures, recipes, and extraction times all at once, trying to regain control. But experienced technicians approach these moments differently, because they understand that extraction inconsistency often begins much earlier, inside the grinder itself. Long before water touches the coffee, unstable particle behavior may already be creating extraction chaos underneath the surface. And in this chapter, we're going to break down exactly how technicians identify those hidden grinder inconsistencies step by step. One of the biggest problems with grind inconsistency is that many people don't even recognize it while it's happening. They only see the symptoms appearing downstream during extraction. But technicians learn to observe patterns carefully. Maybe one shot flows perfectly while the next suddenly chokes. Maybe the espresso runs unevenly through different areas of the basket. Maybe bitterness and sourness appear simultaneously inside the same cup. Maybe the grinder setting keeps drifting day after day without explanation. Maybe shot timing changes dramatically even though the workflow appears identical. These patterns often reveal unstable particle distribution underneath. Because when the grinder produces inconsistent particle sizes, water no longer extracts evenly through the coffee bed. Some particles release flavor too fast, while others barely extract at all. The result becomes confusion in the cup itself, a mixture of over-extraction and under-extraction happening simultaneously. Static electricity is one of the most underestimated forces inside coffee grinding. Most people treat static as a minor annoyance because they only notice the visible mess: grounds spraying onto counters, sticking to containers, or clinging inside the grinder chute. But technicians understand static creates deeper problems than cleanliness alone. Static changes how coffee particles distribute themselves physically during grinding. It increases clumping, causes uneven density inside the basket, disrupts distribution consistency, increases retention buildup, and sometimes even changes extraction behavior shot to shot. Dry environments, high-speed grinding, or friction, roast level, humidity, and grinder design all influence static generation differently. This is why some grinders behave beautifully in one environment and become chaotic in another. Technicians therefore learn to observe not just the espresso itself, but the physical behavior of the grounds during the entire grinding workflow. Static electricity is one of the most underestimated forces inside coffee grinding. Most people treat static as a minor annoyance because they only notice the visible mess: grounds spraying onto counters, sticking to containers, or clinging inside the grinder chute. But technicians understand static creates deeper problems than cleanliness alone. Static changes how coffee particles distribute themselves physically during grinding. It increases clumping, causes uneven density inside the basket, disrupts distribution consistency, increases retention buildup, and sometimes even changes extraction behavior shot to shot. Dry environments, high-speed grinding, or friction, roast level, humidity, and grinder design all influence static generation differently. This is why some grinders behave beautifully in one environment and become chaotic in another. Technicians therefore learn to observe not just the espresso itself, but the physical behavior of the grounds during the entire grinding workflow. Clumping creates one of the most deceptive forms of extraction instability because the grind may initially appear visually acceptable from a distance while hiding uneven density internally. Large clumps create concentrated pockets of tightly packed coffee, while surrounding areas remain looser and less resistant. During brewing, water naturally seeks the path of least resistance, bypassing dense areas while over-extracting weaker sections. This creates uneven saturation, channeling, unstable flow, and flavor imbalance inside the cup. Technicians therefore pay close attention to how grounds distribute physically before brewing even begins, because the structure of the coffee bed determines how water behaves during extraction. Some grinders simply feel frustrating to use because their behavior constantly changes unpredictably. One moment they produce beautiful, fluffy grounds, and the next they create clumps, static explosions, drift, or inconsistent flow resistance. Often this instability comes from multiple small variables interacting simultaneously: burr wear, heat buildup, retention accumulation, environmental humidity shifts, motor strain, calibration drift, bean density changes, or internal contamination. Technicians therefore avoid oversimplifying grinder behavior into single-cause explanations immediately. Instead, they study the overall system behavior patiently until patterns become visible over time. One of the most valuable habits technicians develop is resisting emotional troubleshooting. Instead of reacting impulsively to one bad shot, they begin isolating variables systematically. Has the environment changed? Has humidity shifted? Is the grinder clean internally? Has retention increased? Are burrs aligned properly? Is the motor sounding different? Is calibration drifting? Is static behavior increasing? Is extraction instability consistent or random? This structured observation process transforms grinder diagnostics from stressful guessing into logical elimination. And over time, technicians begin recognizing grinder behavior almost intuitively because they understand how symptoms connect to physical causes underneath. At this point, you should now understand that grinder inconsistency is rarely random. Static, retention, clumping, environmental conditions, burr wear, calibration drift, and internal buildup all interact together to shape extraction behavior long before brewing even begins. And once you begin recognizing those relationships clearly, diagnosing coffee problems becomes far less emotional and far more structured. In the next chapter, we're going to shift from diagnosis into action by breaking down professional grinder cleaning, preventative maintenance systems, and the exact routines technicians use to keep grinders operating consistently over long periods of time. One of the biggest misconceptions in coffee equipment maintenance is the idea that cleaning only matters when something already feels wrong. Most people wait until the grinder begins clogging, producing strange flavors, creating excessive static, drifting during extraction, or behaving inconsistently before finally opening it for maintenance. But experienced technicians think very differently. They understand that maintenance is not something you do after performance declines. Maintenance is what prevents instability from developing in the first place. Because grinders operate in an extremely demanding environment every single day, coffee oils accumulate constantly. Fine particles settle into hidden pathways. Burr chambers trap residue. Heat and friction slowly change internal conditions. Static attracts contamination into difficult areas. Retention builds layer after layer over time. And little by little, extraction quality begins drifting without most users realizing the grinder itself is slowly becoming less stable internally. This is why preventative maintenance matters so much. It preserves consistency before problems become visible. Coffee beans naturally contain oils that become increasingly exposed during roasting and grinding. Every time coffee passes through the grinder, microscopic oil residue coats burr surfaces, exit chutes, declumpers, dosing chambers, and internal pathways. At first, this buildup seems harmless because the grinder continues operating normally. But over time, those oils oxidize, trap fine particles, harden into residue layers, and begin altering the grinder's internal behavior. Fresh coffee starts mixing with stale, oily contamination. Retention increases. Clumping worsens. Particle flow changes. Flavor clarity declines. Some grinders even begin producing slightly rancid or stale flavor notes that users mistakenly blame on old beans instead of internal contamination. Technicians therefore treat coffee oil buildup seriously because they understand that grinders are not only mechanical systems, they are flavor systems. Daily maintenance routines are what separate stable grinders from grinders that slowly become chaotic over time. In professional cafe environments, technicians and experienced baristas understand that consistency depends heavily on simple repetitive habits performed correctly every single day. Removing excess grounds, wiping down exit chutes, purging stale retention, brushing burr surfaces lightly, monitoring static behavior, watching for calibration drift, listening for unusual motor sounds. These small habits may appear insignificant individually, but together they dramatically slow contamination, instability, and mechanical deterioration over time. Preventative maintenance is not about perfection. It's about preventing small issues from accumulating into large problems later. Eventually, every grinder requires deeper maintenance beyond surface cleaning alone. And this is where many users accidentally damage grinders through rushed disassembly, improper cleaning products, aggressive scraping, or poor reassembly practices. Technicians approach deep cleaning methodically and carefully. The goal is not simply removing visible coffee residue. The goal is restoring stable internal operating conditions without disturbing alignment, damaging burr surfaces, contaminating bearings, or altering calibration unintentionally. This requires patience, organization, and understanding how the grinder was designed mechanically. Every removed part should have a purpose. Every cleaned surface should improve function, not just appearance. And every reassembly step should preserve alignment and consistency afterward. Not all cleaning methods are safe for grinders, and one of the biggest mistakes beginners make is treating grinders like ordinary kitchen appliances instead of precision coffee systems. Harsh chemicals, excessive moisture, aggressive abrasives, and incorrect lubricants can damage burrs, corrode internal components, contaminate coffee pathways, or shorten grinder lifespan significantly. Technicians therefore choose cleaning methods based on material compatibility and long-term grinder health. Dry brushing, controlled vacuuming, food-safe cleaners, microfiber cloths, and careful residue removal are often far safer than overly aggressive cleaning approaches that prioritize speed over precision. Many people think static and retention are simply unavoidable grinder personality traits, but maintenance dramatically influences both problems. Dirty exit chutes increase retention. Oil buildup worsens clumping. Fine particle accumulation increases static attachment. Old coffee residue changes coffee flow behavior internally. Technicians therefore understand that grinder cleanliness directly affects workflow consistency itself. Clean grinders evacuate coffee more predictably, reduce contamination, improve dose consistency, minimize clumping, and stabilize extraction behavior over time. Maintenance is not just cosmetic. It directly affects how coffee moves physically through the grinder. One of the biggest differences between beginners and experienced technicians is mindset. Beginners usually perform maintenance reactively after problems become frustrating. Technicians maintain grinders proactively because they understand that stability is easier to preserve than rebuild later. They observe patterns early. They notice subtle changes in sound, resistance, heat, flow, retention, or extraction behavior before major instability develops. They create systems instead of waiting for failure. And over time, this mindset becomes one of the most valuable skills in all coffee equipment maintenance because prevention almost always costs less than repair. At this point, you now understand that grinder maintenance is not simply about cleanliness or appearance. It is about protecting grind consistency, extraction quality, workflow stability, and long-term mechanical performance simultaneously. And once you begin maintaining grinders proactively instead of reactively, the entire coffee workflow becomes more predictable and far less frustrating. In the next chapter, we're going to move deeper into advanced troubleshooting by focusing on grinder motor problems, electrical failures, strange sounds, overheating, jams, and the real diagnostic logic technicians use when grinders stop behaving normally under load. There's a major difference between a grinder that produces inconsistent coffee and a grinder that begins physically failing as a machine. And when grinders cross into real mechanical or electrical failure territory, this is where most people become overwhelmed immediately. Strange sounds appear. Motors hesitate. Grinding slows down unexpectedly. The grinder overheats. The burrs jam. The machine suddenly refuses to start. Sometimes it hums, but doesn't spin. Other times it runs, but behaves weakly under load. And for most users, this instantly creates panic because electrical and motor-related issues feel intimidating. But experienced technicians approach these failures very differently. They do not react emotionally to symptoms. They begin isolating systems logically, because almost every grinder failure leaves clues behind through sound, vibration, resistance, heat behavior, startup patterns, or mechanical movement. And once you understand how to read those clues properly, grinders stop feeling unpredictable. They become systems communicating exactly where the problem is developing internally. One of the most common grinder failures is also one of the most misunderstood. The grinder suddenly refuses to power on entirely. Most people immediately assume the motor itself is dead, but technicians begin much more carefully because total power failure can originate from many different systems. Power switches wear out. Safety interlocks fail. Loose wiring interrupts current flow. Thermal protection systems activate after overheating. Capacitors degrade. Internal fuses fail. Connectors loosen from vibration over time. And sometimes the grinder itself is mechanically jammed so severely that startup protection prevents operation entirely. Technicians therefore avoid replacing expensive components blindly before isolating the actual failure pathway first. A grinder motor humming without spinning is one of the most valuable diagnostic symptoms because it often narrows possibilities dramatically. In many cases, this behavior suggests the motor is still receiving electrical power but cannot overcome startup resistance mechanically. The burrs may be jammed by hardened coffee buildup or foreign debris. Bearings may be seizing. The capacitor may no longer provide enough startup assistance. Excessive fine buildup may have created mechanical drag internally. Technicians therefore listen carefully to the exact startup behavior because the sound itself often reveals whether the failure is electrical, mechanical, or resistance-related underneath. Heat tells technicians an enormous amount about grinder health. Every grinder naturally generates some heat during operation because grinding coffee creates friction and resistance continuously. But excessive heat buildup often reveals deeper instability underneath. Worn burrs force the motor to work harder. Alignment issues increase resistance. Poor ventilation traps heat internally. Dirty burr chambers create friction. Bearings degrade. High-volume café usage stresses components continuously. Over time, heat becomes both a symptom and a cause of grinder deterioration because excessive thermal stress accelerates electrical wear, weakens lubrication, and increases mechanical strain throughout the entire system. Technicians therefore monitor heat behavior carefully during diagnosis instead of ignoring it until catastrophic failure appears. Experienced technicians learn something incredibly valuable over time. Grinders communicate through sound. Healthy grinders develop recognizable operating patterns. When those patterns change, technicians immediately pay attention. Grinding may suddenly sound rougher, louder, sharper, slower, uneven, metallic, unstable, or strained. Vibration may increase unexpectedly. Rattling may appear during startup or shutdown. These subtle changes often reveal developing problems long before catastrophic failure occurs. Burr contact, loose mounts, failing bearings, motor imbalance, foreign debris, damaged burr teeth, or structural instability may all alter the grinder's acoustic behavior. This is why technicians never ignore strange sounds, because the grinder is often warning about instability before total breakdown happens. One small foreign object can create enormous grinder damage extremely quickly. Small stones hidden inside coffee bags, screws, hardened debris, or metallic contamination can jam burrs instantly or damage cutting surfaces permanently. Sometimes the grinder stalls violently. Other times the motor struggles repeatedly under resistance, while users continue forcing operation unknowingly. Technicians therefore inspect grinders carefully after sudden jams because the damage may extend far beyond the initial obstruction itself. Burr teeth may chip, alignment may shift, motors may overheat, bearings may strain under sudden resistance loads. A single jam can create multiple downstream failures simultaneously. What separates experienced technicians from beginners is rarely intelligence alone. It's process. Beginners often jump emotionally between symptoms, replacing random parts hoping something works eventually. Technicians slow everything down. They isolate systems one at a time. Is the issue electrical, mechanical, thermal, resistance-related, alignment-related, environmental? They observe startup behavior, operating sound, heat development, vibration patterns, grind consistency, extraction response, and internal condition together before making conclusions. This structured approach dramatically reduces wasted time, unnecessary repairs, and expensive mistakes because diagnosis becomes logical rather than reactive. One of the most important lessons in all equipment diagnostics is realizing that failure rarely appears randomly. Most grinder breakdowns begin long before the visible symptom itself finally appears. Heat builds slowly. Burr wear increases gradually. Resistance accumulates. Alignment drifts. Maintenance gets delayed. Small warning signs appear quietly over time. Technicians therefore train themselves to recognize instability early before catastrophic damage develops later. Because preventing failure is always easier, cheaper, and more efficient than rebuilding after collapse already happens. At this point, you now understand how technicians approach rail grinder failures logically instead of emotionally. Motors, heat, electrical systems, jams, vibration, sound changes, and mechanical resistance all become diagnostic clues instead of sources of panic. And once you begin recognizing those clues properly, grinders become far less intimidating to troubleshoot because every symptom starts connecting back to physical systems underneath. In the next chapter, we're going to move beyond repair itself and focus on advanced workflow optimization, retention reduction, static control, dosing strategies, café efficiency, and the hidden techniques professionals use to make grinders perform cleaner, faster, and more consistently every single day. There's an important stage every serious coffee technician eventually reaches. At first, the goal is simply getting the grinder working again. Then the focus shifts toward consistency and reliability. But after enough experience, something changes completely. You begin realizing that true grinder mastery is not only about repair, it's about optimization. Because two grinders in perfect mechanical condition can still perform very differently depending on workflow, environmental conditions, preparation habits, retention management, and daily operating routines. This is where advanced technicians separate themselves from average users. They don't simply ask, "Does the grinder work?" They ask, "Is the grinder operating at its highest level consistently every single day?" And in this chapter, we're going to break down the hidden workflow systems professionals use to reduce static, minimize retention, improve dosing accuracy, stabilize extraction, and create cleaner, faster, more repeatable grinding performance long-term. One of the biggest mistakes beginners make is assuming grinder performance exists independently from the person using it. In reality, workflow itself directly influences extraction consistency. Dosing habits change retention behavior. Grinding speed changes static generation. Purging routines affect freshness. Distribution methods affect density. Environmental conditions affect particle movement. Even the timing between grinding and brewing changes how the coffee behaves physically inside the basket. Technicians therefore study workflow as part of the grinder system itself. Because unstable routines often create unstable coffee even when the grinder is mechanically healthy. Static is one of the most frustrating workflow problems in modern coffee grinding because it affects cleanliness, dose consistency, distribution quality, retention behavior, and extraction stability simultaneously. But experienced technicians understand that static is not random. It's the result of friction, environmental dryness, burr speed, bean moisture, roast level, grinder design, and particle interaction. And once you understand those variables, static becomes far more manageable. Some technicians reduce static through environmental humidity control. Others modify grinding workflows. Some optimize for cleanliness. Others use controlled moisture techniques like the Ross droplet technique to stabilize particle behavior before grinding. The goal is not eliminating static perfectly, because some static always exists, but reducing its disruptive impact on consistency. Retention becomes especially important once users begin chasing higher levels of consistency, because even small amounts of stale retained coffee can influence flavor clarity and dose stability significantly over repeated extractions. Advanced technicians therefore focus heavily on how coffee travels through the grinder system from beginning to end. They study dead spaces inside exit chutes. They monitor dose exchange consistency. They observe how declumpers affect evacuation flow. Some grinders naturally retain more coffee than others due to internal geometry and pathway design. But maintenance, workflow, purging habits, and grinder modifications can dramatically reduce the negative effects of retention over time. One of the biggest workflow debates in modern coffee grinding revolves around single dosing versus traditional hopper-fed grinding. Single dosing prioritizes freshness, lower retention, and tighter dose control by grinding only the exact amount needed for each shot. Hopper workflows prioritize speed, consistency under volume, and stable bean feed pressure during repeated operation. Neither system is automatically superior in every environment. Café workflows often benefit from hopper stability under heavy demand, while home enthusiasts may prioritize freshness and flexibility through single dosing. Technicians therefore evaluate workflow based on usage goals rather than blindly following trends. Many people underestimate how dramatically the environment affects grinder behavior day after day. Humidity changes static generation. Temperature changes bean brittleness. Air moisture changes particle flow. Even altitude and climate can subtly influence extraction behavior. This is why grinders that behave perfectly one season may suddenly feel unstable months later without any mechanical failure occurring at all. Experienced technicians therefore monitor environmental shifts constantly instead of assuming the grinder itself is always the source of instability. Sometimes the machine hasn't changed, the environment around it has. Advanced workflow optimization is not only about extraction quality. It's also about reducing friction during daily operation itself. Technicians and professional baristas constantly optimize movement efficiency, cleaning routines, dosing consistency, grinder accessibility, and maintenance simplicity because smoother workflows reduce mistakes under pressure. A grinder that creates less mess, evacuates coffee cleanly, maintains calibration stability, and operates predictably allows the user to focus more energy on extraction quality instead of constant correction and cleanup. Workflow efficiency therefore becomes part of long-term consistency itself. Real grinder mastery does not look dramatic from the outside. It looks calm, controlled, predictable, stable. Technicians who truly understand grinders stop reacting emotionally to every extraction change because they understand the relationships underneath the system. They notice small changes early. They maintain equipment proactively. They adjust workflow logically. They understand how static, retention, calibration, environment, and grinding behavior interact together continuously. And over time, consistency stops feeling accidental. It becomes repeatable because the entire system, machine, workflow, maintenance, and technique begins operating together as one controlled process. At this point, you now understand that advanced grinder performance depends on far more than burst sharpness or motor power alone. Workflow, environment, maintenance, retention management, static control, and operational habits all shape extraction quality continuously every single day. And once you begin optimizing the entire grinding system instead of chasing isolated fixes randomly, consistency becomes dramatically easier to achieve. In the next chapter, we're going to bring everything together by focusing on complete diagnostic logic, how professional technicians approach grinders systematically from symptom to cause to solution without confusion, panic, or wasted repairs. One of the biggest differences between beginners and experienced technicians is not tools, intelligence, or even years of experience. It's structure. Beginners often approach grinder problems emotionally and randomly. Something tastes wrong, sounds strange, or behaves inconsistently, and they immediately begin changing multiple variables at the same time, hoping one adjustment accidentally fixes the issue. They change grind size, clean random components, adjust extraction recipes, open the grinder unnecessarily, or replace parts blindly without fully understanding the actual root cause underneath. Professional technicians work differently. They follow diagnostic logic. Every symptom becomes information. Every sound, vibration, extraction change, resistance shift, temperature pattern, and workflow inconsistency becomes part of a larger system analysis. And instead of reacting emotionally, technicians move step by step from observation to isolation to confirmation. This chapter is about building that mindset completely. Because once you understand how technicians think diagnostically, grinders stop feeling unpredictable and chaotic. They become understandable systems with identifiable causes behind every symptom. One of the most dangerous habits in equipment repair is assuming the cause before gathering enough evidence. A grinder may suddenly produce sour espresso, but that does not automatically mean the burrs are worn. The motor may sound louder, but that does not automatically mean it is failing. Extraction may become inconsistent, but that does not automatically confirm grinder damage. Technicians therefore avoid jumping to conclusions too early because many different failures create similar symptoms. Static problems may resemble grind inconsistency. Retention buildup may imitate burr wear. Environmental humidity may affect extraction similarly to calibration drift. And without structured diagnosis, people often replace perfectly functional parts while the real issue remains unresolved underneath. Professional diagnosis always begins with clearly defining the symptom itself, not vague frustration, not emotional reactions, specific observable behavior. Is the grinder producing inconsistent particle sizes? Is extraction timing drifting unpredictably? Is static suddenly increasing? Is the motor overheating? Is retention worsening? Is the grinder louder than normal? Does the problem happen continuously or intermittently? Under heavy load or only occasionally? Technicians narrow problems down carefully because precise symptom definition dramatically reduces diagnostic confusion later. Once the symptom is identified clearly, technicians begin isolating variables one by one instead of changing everything simultaneously. Has the environment changed recently? Are the beans fresh? Is the grinder clean internally? Are burrs aligned correctly? Is calibration stable? Has static behavior increased? Is retention accumulating more than usual? Is the motor behaving differently under load? This isolation process is critical because changing multiple variables at once destroys diagnostic clarity completely. If 5 things change simultaneously, there's no way to know which change actually affected the outcome. Technicians therefore protect diagnostic accuracy by controlling variables carefully throughout the troubleshooting process. Beginners often focus on isolated components while ignoring how the grinder behaves as a complete system. Technicians think differently. They understand that burrs, motors, alignment, retention, static, environment, workflow, calibration, and maintenance all influence each other continuously. A grinder may appear to have a burr problem when the real issue is heat stress from motor strain. Retention buildup may create extraction instability that looks like alignment drift. Environmental dryness may create static severe enough to disrupt dosing consistency entirely. Technicians therefore diagnose relationships between systems instead of obsessing over individual components alone. One of the most valuable habits technicians develop is confirmation before action. They do not replace parts simply because something seems likely. They verify the cause as carefully as possible first. If burr wear is suspected, they inspect extraction behavior, grind consistency, burr condition, and calibration range together. If motor stress is suspected, they evaluate heat, resistance, startup behavior, and sound patterns collectively. Confirmation reduces unnecessary repairs dramatically because many symptoms can imitate each other deceptively. Professional diagnosis is about certainty whenever possible, not assumptions. Over time, experienced technicians begin recognizing patterns almost instinctively because they've seen similar combinations of symptoms repeatedly. Certain sounds often connect to bearing problems. Specific extraction inconsistencies point toward alignment drift. Excess fines combined with calibration instability may suggest burr wear. Static combined with heavy retention may reveal environmental and maintenance issues together. This pattern recognition is not magic. It develops through observation, repetition, and structured thinking over time. And the more systems you diagnose carefully, the faster your brain begins connecting symptoms to likely causes naturally. Once you stop approaching grinders emotionally and start approaching them diagnostically, everything changes. Problems become less intimidating. Repairs become more logical. Workflow becomes calmer. Extraction becomes more consistent. You stop chasing random solutions because you understand how to analyze the system step by step. And most importantly, you stop depending entirely on luck or guesswork every time something changes unexpectedly. This mindset is what transforms someone from a frustrated coffee user into someone who truly understands equipment behavior professionally. At this point, you now understand the complete diagnostic foundation behind professional grinder troubleshooting, from symptoms and variable isolation to system analysis, confirmation, and pattern recognition. And once you begin applying this structured approach consistently, grinders stop feeling unpredictable because every behavior starts pointing toward understandable causes underneath. In the next and final chapter, we're going to bring everything together by focusing on long-term mastery, professional habits, continuous improvement, and how to continue growing from simply repairing grinders into truly understanding coffee equipment at a technician level. At the beginning of this course, grinders may have felt complicated, unpredictable, mechanical, intimidating, or even overwhelming. Many people start their coffee journey believing grinders are mysterious machines that either work or fail randomly without warning. But now, after everything we've covered together, that perspective should be changing completely. Because the deeper truth is this: grinders are not random. They are systems. Systems governed by mechanics, alignment, heat, friction, resistance, calibration, workflow, maintenance, and observation. And once you begin understanding those systems properly, something powerful happens. You stop reacting emotionally every time extraction changes. You stop panicking when strange sounds appear. You stop guessing blindly when consistency disappears. Instead, you begin thinking logically like a technician. You observe. You isolate. You analyze. You understand relationships between symptoms and causes. And that mindset shift is far more valuable than any single repair technique alone because it changes how you approach every coffee machine and grinder you will ever work with in the future. Most coffee users never truly understand their grinders because they remain trapped in reactive thinking. They search for quick fixes instead of understanding systems. They chase recipes instead of studying extraction behavior. They replace parts without diagnosing root causes. They depend on forums, random advice, or emotional adjustments every time consistency changes. And because of this, they stay dependent on guesswork indefinitely. Technicians become different because they commit to understanding how equipment behaves underneath the surface. They study patterns. They build structured habits. They observe carefully. They stop looking for magic answers and start building mechanical understanding step by step. That is what creates real long-term confidence. One of the most underrated technician skills in the entire coffee world is observation. Noticing small changes before they become large failures. Recognizing unusual sounds early. Detecting subtle extraction drift before consistency collapses completely. Observing retention patterns. Feeling resistance changes during adjustment. Watching how grounds behave physically during grinding. Listening to the motor carefully under load. Experienced technicians build incredibly strong observational awareness over time because equipment constantly communicates its condition through behavior. And the earlier you recognize those changes, the easier problems become to correct before major damage develops. Long-term grinder performance depends far more on consistency than intensity. Small maintenance habits repeated regularly are far more valuable than aggressive deep cleaning performed only after major problems appear. Technicians build routines. They clean proactively. They monitor retention. They inspect burr condition periodically. They observe calibration stability. They prevent contamination from accumulating excessively. And over time, these habits dramatically extend grinder lifespan while protecting extraction quality continuously. Maintenance becomes less about reacting to emergencies and more about preserving stable operating conditions every single day. Every grinder you work on teaches something new if you pay attention carefully enough. Over time, you begin recognizing recurring patterns. Certain sounds connect to certain failures. Specific extraction behaviors point toward calibration instability. Particular static patterns reveal environmental changes. Burr wear creates familiar symptoms repeatedly. And slowly, experience begins compressing diagnosis time dramatically because your brain starts building internal reference points automatically. This is how technicians develop intuition, not through guessing, but through repeated structured observation over long periods of time. There is a major mindset shift that happens when someone stops being only a coffee consumer and starts thinking like a technician. Coffee users mainly focus on outcomes, whether the espresso tastes good or bad. Technicians focus on systems, why the outcome happened in the first place. They study extraction mechanics, workflow consistency, grinder behavior, resistance changes, maintenance patterns, and machine communication. And once you begin thinking this way consistently, you stop feeling dependent on luck, random internet advice, or emotional troubleshooting because you understand how to analyze problems yourself. One of the most important truths about coffee equipment mastery is that learning never really ends. Every grinder design behaves differently. Every environment introduces new variables. Every café workflow creates unique challenges. New burr geometries appear. Different roast styles affect extraction differently. Even experienced technicians continue learning constantly because coffee equipment is a living field built around mechanics, physics, workflow, and human behavior interacting together continuously. The goal is not becoming perfect. The goal is becoming observant, adaptable, structured, and continuously improving over time. By this point, you now understand far more than basic grinder cleaning or random troubleshooting tricks. You understand how grinders actually function internally. You understand burr wear, alignment, calibration, retention, static, workflow optimization, motor diagnostics, preventative maintenance, and structured troubleshooting logic. Most importantly, you now understand how technicians think. And that knowledge changes everything because it gives you something far more valuable than memorized fixes. It gives you clarity, the ability to observe problems calmly, the ability to diagnose logically, the ability to maintain consistency proactively instead of reacting emotionally after failures already happen. And whether you continue improving your own home setup, maintaining cafe equipment, helping others solve coffee equipment problems, or even pursuing technician work professionally, this mindset becomes the real foundation underneath all long-term success in coffee equipment repair and maintenance. If this course helped you understand grinders and coffee equipment at a deeper level, continue building your technician skills through hands-on observation, maintenance, and structured diagnosis every single day. The more systems you study carefully, the more confident and capable you become over time. And remember, real technicians are not defined by memorizing repairs. They are defined by understanding systems clearly, thinking logically under pressure, and solving problems with precision instead of guesswork.